looking at the mirror.
All right, you have one title to add to your notebook today. Solving radical equations.
Miss Smith, when did we go from 114 to 151?
Yeah.
Oh, sorry.
I wrote 151.
Because I keep cutting and pasting from my other one and it's not working. Because I keep forgetting to change things. Just 115. Just page 115.
John's over here complaining about it. We skipped a lot of pages.
Yeah, we did, apparently. Which means every one of these is probably messed up then. No, that one's right. What the heck?
She's like, what the heck?
Can I cut it in half?
All right. You're going to take this piece of paper and cut it along your dotted line. Cut it along your dotted line. Guys, when the scissors are out, you need to grab scissors. You know better.
No, I don't. I think he didn't whisper. No, I bet John didn't whisper.
No, I cut it.
I bet you were talking about it. I was talking about it. I bet you I said first you didn't say.
Okay. The first piece I want you to find is this half that says radicals on both sides and lay it in front of you just like this.
I think I'm going to do this.
Okay. You're going to take the top and fold it down so your titles are stacked on top of each other.
Oh, I know what we were doing.
Like this. Okay. So put radical on both sides, facing up, take the top and fold it down. Other page. There we go. Radicals on both sides should be at the bottom. Okay, once you have that, take this other piece, put extraneous solutions at the bottom. Take the piece you just folded and set it inside so its titles stack on top of that one. And take the top and fold it down.
Are we making a foldable?
You've got a flip book. Yay! Okay, and then somebody needs to grab the stapler over there, but you're going to take the stapler and you're going to put one on the left and one on the right. Keep it as close to the top as possible so you're not cutting off any problems. This down.
The one with us?
The huge thing.
Now,
The one that used to have that thing. Or armor piece and all that. But you used to have armor cast.
He stays at the library.
Staple here and a staple here, don't staple too far down.
Armor,
He
it was
stays at the library.
no, he was writing down. Oh, the little Robbie said lie down.
In like sunglasses.
Yeah.
Yeah, I know. He's weird.
Yes.
And he was looking back.
He was he looked at you like this, something like that.
You need a ride.
He's so weird. And he be going around listening to next like that's his place. Like, I saw him on the road this morning, and he was
Guys, stop with the conversations. You're blasting all over the internet. It's rude.
It doesn't have any more. Oh.
Okay, today we're going to solve radical equations, just like you solved linear equations. So our goal is to get x by itself.
I think this is out of Staples.
Can you open it up and check? I have more.
Yep.
I got you.
How do you open this one, Mister? You said, ouch. How do you put this one on? Let's see if we have to.
Stuck again. Image is filled.
We can go ahead and glue it.
You can go ahead and glue it. It's going to glue. Keep it close to the top of page 115 so we can write steps on the bottom. You're going to eventually learn how to solve every type of equation out there. You're going to learn how to solve exponential. You're going to learn how to solve absolute value. So we've already done quadratic and we've done linear. Now it's radical. Okay, this top part says, if two expressions are equal, then their squares are equal. So what this means, if I have something like 2 equals 2, then that means 2 squared equals 2 squared. Okay, if I square the left side and I square the right side, I haven't changed anything. It's still equal. Okay. So just like when you had something like 4x equals 8 and you divide it by both sides, what you do to one side, you do to the other. Same thing happens here. If I square the left side, I also have to square the right side. So we're going to talk about radicals on one side of the equation first. So down here, we're going to write steps. So we need radicals on one side, so you know what you're solving for. Radicals on one side. On the other side, we're going to put radicals on both sides. So we'll have steps for both. Okay, what do I do if I only have a radical on one side, and what do I do if I have it on both? So, step number 1 for radicals on one side. We want to isolate the radical. What does it mean to isolate a radical?
Separate.
Separate. Get it by itself. Okay? If you are in isolation, you are all by yourself. There's nobody else with you. So, the first thing we want to do is isolate the radical. Step 2 is going to be square both sides. What happens if I square a square root? What is the opposite of square rooting something? Okay, what's the opposite of squaring something?
No.
If I have something like six squared. What's 6 squared?
6 times
6 times 6, which is
12.
36. Not 6 times 2, 6 times 6. How do I turn 36 back into 6?
Square root it.
Square root it. So what's the opposite of squaring something?
The exponent. I mean, square root.
Square rooting it. So the opposite of square rooting something is to square it. So if I have the square root and I square that side, all it does is it gets rid of that square root. It's the opposite of it. Just like if you had x plus 3 and you would subtract to get rid of it because it's opposite, the opposite of the square root is squared. Okay. And the last step, check your answer. You're going to end up with an answer. You always need to check your answer. It's going to come vitally important when we get to extraneous solutions to check your answer. Okay, so let's use these steps up top. Example number 1. The first thing I want to do is isolate my radical. Get it all by itself. So what do I need to get rid of if I want this square root all by itself?
3 equals 10.
Okay.
So
So,
subtract 3 from both.
Subtract 3 from both sides. I need to get rid of that positive 3. Square root of x is what is left because this cancels. Equals, what's 10 minus 3? 7. Okay. Step 2 said once my radical's isolated, I need to get rid of that square root. So I'm going to square both sides. So what this does is it gets x all by itself. So I have x alone. And then what's 7 squared? 49. That should be your answer. The last step we want to do is check it.
We plug it in.
So we're going to plug it in. So the square root of 49 plus 3 equals 10. So you can either do this by yourself or plug it into your calculator at this point. What's the square root of 49?
7.
7. So 7 plus 3 equals 10. What's 7 plus 3? 10. So 10 equals 10. True statement. It checks out. 49 is our solution.
So at the end, when you check it, it has to equal what it equals? Like, at the
It has to come out to be a true statement.
Oh, okay.
So if you end up something down here like -2 equals +2, the answer that you got, while it is an answer, it's not an actual answer. It's called what we call an extraneous solution. Okay. We'll talk about that in the third flat. Okay, example number 2. Again, my job is to get this radical all by itself. So if you want to draw a box around just the radical, so you can see what's outside of it.
Add 3 to both sides.
What's happening if I have -3 right next to my square root? It's multiplied, okay? It's the same as having something like this, -3x equals 6. How would you get x by itself? We would divide by -3, okay? It's not being subtracted from it, it's multiplied. Okay, so whenever it's right out front of the radical, and Anna, that's what I was talking about yesterday, where you can have big numbers out front and then the little tiny indexes. So just be very careful with that. Okay, so this is a number being multiplied, it's not an index. So to get rid of this, we need to divide by -3. So the square root of x equals what? What's -18 divided by -3? 6. Your negatives cancel out. Negative divided by a negative is a positive, and 18 divided by 3 is 6.
So now we just go back and plug it in.
Okay, no, we're not done yet. This is the square root of x.
Oh, yeah.
We need to get rid of this square root. Again, the opposite of it is to square it. So x equals, what's 6 squared? 36. Now we plug it back in. So -3 times the square root of 36 equals -18. What's the square root of 36? 6. So -3 times 6 equals -18. And -3 and 6 give me, we're multiplying. It's -3 times 6.
-18.
-18. -18 equals -18. It checks out. 36 is an actual solution to this problem.
Oh, so that's why on some math tests, that's why it has a solution, not no solution.
Because you can end up finding two answers when you solve it, and neither one of them may work when you plug it back in. Okay? Example number 3. Again, my job is to get this by itself. So I need to get rid of everything outside of that. What do I do first? What do I need to get rid of first?
The -5.
The -5. Remember, if you had 2x minus 5, you would get rid of your 5 first. Still the same concept. So how do I get rid of a -5?
Add 5 to both
Add
sides.
5 to both sides. So 2 square roots of x equals +4. Again, I still need this by itself. It's still not alone. So now I get rid of the 2. Perfect. We divide by 2.
2.
Square root of x equals 2. And how do I get x by itself again?
Square root.
Not
Square
square root. Square it.
So it's 4.
So x equals 4.
Now we go back and plug it in.
Now we go back and plug it in. 2 times the square root of 4 minus 5 should equal -1. What's the square root of 4?
2.
2. 2 times 2 is
4.
4. Minus 5 is
0.
4 minus 5.
1.
-1. Okay, so yes, 4 is a solution to my problem. Questions or problems on these?
Are we gonna do home? Are we gonna have homework tonight?
A little tiny puzzle. That's all. Okay, we've got 2 examples under this flat. Now we're looking at radicals on both sides. So, step 1. Once you have a radical on the left and a radical on the right, we need to get rid of those radicals. So our first step is to square both sides to get rid of that radical. Step number 2, solve the equation. For x, or the variable, let's put it that way. Because it may not always be x, you know, they like to throw in r and n and t.
I accidentally put fox.
And then finally, your last step, check your answer. Again, this is going to be vitally important to always check your answer. Questions or problems? Yeah? Let's work through these steps. Example 4. Okay, I have a radical on the left and a radical on the right. So we need to get rid of them. We're going to square both sides. When I do that, all that does is cancel out your radical. It does nothing to what's underneath. So when I square both sides, I'm left with x plus 4 equals 2x minus 1. Now I need to solve your equation for x. So x is on one side, numbers on the other. How do I do this?
You can add 1.
You want to add 1 to both sides. Okay. So I'm going to add the 1. That cancels my 1 out over here. And I have x plus 5 equals 2x.
And then you can subtract the x from 2x.
Okay, so we want to move the x's to the other side, so I'm going to subtract x. So that cancels this out and leaves me with 5 equals. What's 2x minus x? X. 1x. Or just x. So 5 should be my answer. Again, we need to plug it in and check. So the square root, 5 plus 4 equals the square root of 2 times 5 minus 1. Okay, all I did was replace your x's with a 5. What do I get when I take 5 plus 4? 9, good. Equals, what's 2 times 5? 10 minus 1 is 9. Does the square root of 9 equal the square root of 9?
Yes.
Yes. Check. It works. 5 is a solution to my equation.
It's not hard.
We haven't gotten to the hard part yet. Because then we've got to go back to your factoring.
Oh, I hate
Oh.
factoring.
Example number 5. I have a radical on one side, radical on the other. How do I get rid of them?
You can subtract 4.
I got to get rid of these radicals first.
Square it.
Square both sides.
And now you can subtract 4.
Now we can subtract 4. Okay, so we get 3x plus 4. These cancel out, so I'm just left with x on this side. Now what?
Subtract 3x.
Subtract 3x. 4 equals, what's x minus 3x?
Negative 2x.
Negative 2x. And my last step then is to?
Divide.
Perfect. So negative 2 equals x. Be careful, we're plugging in a negative now. So, square root of 3 times negative 2 plus 8 equals the square root of negative 2 plus 4. So, solve what's underneath the left radical first. What's 3 times negative 2?
Negative 6.
Negative 6 plus 8?
Negative.
Positive 2. Perfect.
Surprise.
What's negative 2 plus 4? 2. Square root of 2 equals the square root of 2. It's good, which means negative 2 is a solution to this equation.
I'm so sick.
All right.
Oh my God.
Extraneous solutions. You're going to use all the knowledge of solving with a radical on one side, but now we're going to have extraneous solutions, which means we're going to end up with answers that may or may not work. Okay, so I only have a radical on one side of the equation. Okay, I have a radical on one side. How do I get rid of it? What was the first step to radical on one side?
Isolate.
Isolate the radical. Is my radical all by itself?
No.
There's stuff outside of my radical?
No.
No, so it's all by itself. It doesn't matter what's underneath of it. Isolating it means there's nothing on the outside of it. Okay? So, step 1 is done. Step 2 says to do what?
Square both sides.
Square both sides. So, I square the right-hand side and the left-hand side. So, the left-hand side, I have x squared equals, when I square the right-hand side, I'm left with 42 minus x. Again, it does nothing to the radicand underneath the radical. All it does is get rid of that square root sign. This is where the fun comes in. I don't just have x now. I have x squared. When you see x squared, what kind of an equation is that now? When did we deal with x squared?
Function?
It was a function, but what kind of a function was it?
Factory? No, wait.
We did this all in Unit 2. What kind of equations did we talk about in Unit 2?
Quadratic.
Quadratics. Okay, so as soon as you see that x squared, that should tell you quadratic. We need to factor. Here we go. So remember, to factor, we need the equation set equal to 0, and we want my x squared to stay positive. So it's positive over here. Let's move everything else to the left. So I need to move x to the left. How do I do that?
By subtracting it. Yeah.
Adding it. Good. It's subtracted on that side. We need to add it. So x squared and x are not the same, so they stay separate, and that's going to equal 42. Now I need to move my 42 over. How do I do that? Subtract it. It's positive. Perfect. So I end up with x squared plus x minus 42 equals 0. Once you have it equal to 0, we now know we can factor. Okay, so remember, when we factor, your C value goes on top, negative 42. Your B value goes on bottom, positive 1. So I need numbers that multiply to give me 42.
6 times 7.
6 times 7.
Yeah.
Anything else?
1 times 42.
1 times 42.
So it's 6, 7.
2 times 21. You say it's 6, 7. Okay? I agree. Remember, this is a negative 42, which means they need to subtract to give me 1.
So
If my 1 is positive, which number is positive? Is it my 6 or my 7?
7.
7, good. So x plus 7, x minus 6. Is this equation factored?
Yes.
Okay, remember, these are not equal to x yet. They're equal to 0. So x plus 7 equals 0, and x minus 6 equals 0. We have to actually solve our factors. So if x plus 7 equals 0, how do I get rid of the 7?
Subtract 7.
Subtract 7. So x equals negative 7. If I have x minus 6 equals 0, how do I get rid of 6?
Subtract. Add 6.
Add 6. So x also equals 6. So now we have 2 solutions. At least we think. We need to plug them in and see what works and what doesn't work. So if we plug in negative 7 equals the square root of 42 minus negative 7. So negative 7 equals the square root. What's 42 minus negative 7? What happens to that minus negative? What does a double negative do?
Become a positive.
It becomes a positive. So what's 42 plus 7?
What's 42 plus 7?
What's 42 plus 7?
49.
49.
49.
Okay. What's the square root of 49?
7 times 7.
7. Does negative 7 equal 7?
No.
No. So guess what? This is an extraneous solution. It doesn't work. So while we solved and got it, it's still not an actual answer. We must check 6. Just because this one doesn't work doesn't mean that this one will. So we have to check them both. 6 equals the square root of 42 minus 6. So 6 equals, what's the square root of 42 minus 6? Or actually, what's 42 minus 6? Let's do it that way. What is it?
32.
36, perfect. And what's the square root of 36?
6.
Does 6 equal 6?
Yes.
Yes. So x plus 6 is an actual solution. I know it is a lot of work. This one's even more work. Again, radical on one side. We need to isolate it first. Is my radical all by itself? Yes, there's nothing outside of it. Again, if you need to look, put a square around your radical. If there's nothing outside of that square or rectangle, then it's already isolated. So that takes us to step 2, which was what?
Square both sides.
Square both sides. Notice I put parentheses around anything that I square. Bless you. So on my left, I'm left with 2 minus x. Here comes my problem. X plus 4 squared. What does it mean to square something?
Multiply.
Multiply what times what? So like if you had 6 squared, it would be what?
6 times 6.
6 times 6. So when I have x plus 4 squared, that means I have x plus 4 times x plus 4.
So that'll be 2 squared.
What do I do when I have a binomial times a binomial? You called it a 4-letter word back in middle school or in 9th grade.
Combine numbers?
Begin with an F. What did you do to multiply two binomials? No. Factoring is going back and getting this. How do I turn around and turn this into a quadratic?
I was going to say fraction.
How about, watch what I do. You remember doing this?
Oh, yeah.
What was that method called?
I know it started with the D or something.
No, well, you can call it that too. The main word you should know begins with an F, and it stood for something.
I don't remember.
Math teacher fail. FOIL.
Oh, yeah.
Oh,
The
yeah.
FOIL method,
Yeah.
I
Okay.
never learned it like that.
where you take your first term and your first term and multiply it together. So what is x times x? X squared.
So what was the D word?
Distribute.
That word. So that's how I learned it.
Okay. So FOIL or distribute, whatever you want to call it.
Distribute.
Isn't it when you draw the box? No, that's
You can.
Oh,
What she's talking about is doing it like this.
I don't call it FOIL. I learned this in elementary.
If you're better with the box method,
No, it's not the box method. It's lettuce. I don't
Lettuce?
know. Yeah, I learned multiplication like that. Yes.
is this what you're talking about?
Yeah, but I learned my multiplication.
Okay.
Like that.
So you have x and x go in this box. That gives me what?
2x. Well, x squared.
X squared. X and 4 meet here.
And then 4x.
So this is 4x. X and 4 meet here.
4.
4x. And 4 and 4 meet here,
4 squared.
which is 16. So then these two both have x's. They go together. So you get x squared plus 8x plus 16. Okay, that works. I don't care which way you learn to factor, multiply, distribute, FOIL, whatever you want to call it.
That's what we're doing in biology with the genes and stuff
Yeah.
like that.
Well, good. Maybe this will help then. Fantastic. Use what you're doing in science class. Punnett squares. I love Punnett squares.
I don't like it.
You find out if you could have blue eyes or brown eyes.
Yeah, and then with the big B, little B.
Okay, so there's that method. FOIL. It says to take your first term times your first term, which was x times x, which is x squared. Your outer terms. So your x on the outside and your 4 on the outside multiplied together give me 4x. My inner terms. 4 times x.
4x.
4x. And finally, my last terms, 4 times 4. 16. Guess what? You still have two x terms that go together. So x squared plus 8x plus 16 equals 2 minus x. Here we go with that x squared again. We've got a quadratic. We're going to have to FOIL. So we need to get everything equal to x or equal to 0 first. So I need to move my x to this side. How do I do that? Add it. Where does it go? What term does it go with on this side?
8x.
The 8x. So plus x. I'm going to put it right underneath the 8. I'm going to do the 2 at the same time. 2's over here. How do I move it over here?
You can subtract it.
Subtract it. And what does it go with?
16.
16. So we end up with 0 equals x squared plus 9x plus 14. Okay, 14 on top, 9 on the bottom. So I need two numbers that multiply to give me 14. What do we got?
7 and 2.
7 and 2, 1 and 14.
But it's 7 and 2, so.
It's 7 and 2. So is this plus plus or minus minus?
Plus.
Plus plus. It has to take the sign of my middle term. So this is x plus 7 and x plus 2. Set them both equal to 0 and solve. So x equals what if I have x plus 7 equals 0? How do I move that 7 to the other side?
Subtract it.
We subtract it. So x equals negative 7. And how do I get 2 to the other side? Subtract it as well. So x equals negative 2. Let's plug them in and see what works. So we've got the square root of 2 minus negative 7 equals negative 7 plus 4. What's 2 minus negative 7? Remember what that double negative does?
It's 2
Makes
plus
it positive, so
7.
it's 2 plus 7, which is
9.
9, equals, what's negative 7 plus 4?
Three. Negative 3.
Negative 3. What's the square root of 9?
3.
3 equals negative 3. Does that work? No, 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 which means negative 7 is not a solution. Let's try negative 2. The square root of 2 minus negative 2 equals negative 2 plus 4. Again, I've got that double negative. So what's 2 minus negative 2? Say louder.
4. We're not at the library, John.
Right. We're not at the library. You can talk. Negative 2 plus 4 is what on the right-hand side? Remember, negative 2 plus 4 can also be read as 4 minus 2.
2.
2. What's the square root of 4?
2.
2. Does 2 equal 2?
Yes.
Yes. So x equals negative 2 is a solution to this problem. Questions? Okay. So what I have for you for the rest of the period is task cards. I don't care if y'all want to work together as a big group. You can do that, or you can work in small groups, whatever. There's the whiteboard available if somebody wants to come up and like the entire class works through it with you and you talk about it, and I can be back here answering any questions that you have as you work, but that's what you're going to work on for the rest of the period. Okay.